In this video, we're going to take a look at if-then statements. If-then statements are called conditional statements. The portion following the if is called the hypothesis. And the portion following the then is called the conclusion. We like to write in notation. So if we have a conditional statement, it's of the form P then Q, and this is read if P, then Q. And here the P is the hypothesis and Q is the conclusion. Sometimes we need to rewrite if-then statements in if-then form, and it helps to clarify what's being said. So here's an example. Perpendicular lines intersect. So if I were to rewrite that in if-then form, I would say if two lines are perpendicular, then the lines intersect. My hypothesis, what is given, is that the lines are perpendicular, and what I can conclude from that is that they are intersecting. All right, so pause the video and go ahead and give this one a try. An angle of 40 degrees is acute. So we want to write that in if-then form, then identify the hypothesis and conclusion. Okay, so if an angle measures 40 degrees, then the angle, or then it, is acute. So we just have to make sure that when we write our statements, we're making them grammatically correct. Okay, so an angle measuring 40 degrees. This is the hypothesis. I am giving you an angle that measures 40 degrees, and you are concluding that it is acute. The hypothesis does not include the word if, and the conclusion does not include the word then. Okay, so that's our first statement, if P then Q, and that's called our conditional. All right, the converse. The converse of a statement is formed by exchanging the hypothesis and the conclusion. The converse of if P then Q is if Q then P. All right, so we literally switch the hypothesis and the conclusion. So for our example that we were using up and above, the converse of if two lines are perpendicular, then the lines intersect. When we switch perpendicular, intersecting, we get if two lines intersect, then the lines are perpendicular. The converse of a conditional statement is not always true. The way that we show that a converse is false is we give a counterexample. It only takes one counterexample to make a statement false. So here, if two lines intersect, well, let's look at the conditional statement here. If two lines are perpendicular, then the lines intersect. That is a true statement. Lines can either intersect, be parallel, or be skew. And if lines are perpendicular, then in fact they must intersect. Now what about the converse? If two lines intersect, then the lines are perpendicular. This is a false statement. While it can be true, it's not always true. And our counterexample can simply be something like this. And if this were 30 degrees, and that were 150 degrees, we have intersecting lines that are not perpendicular. Okay, so now your task is to write the converse of adjacent angles have a common side. Write the conditional here, switch the hypothesis and conclusion and write the converse, and then determine whether it is true or false, and if false, give a counterexample. Pause the video and go ahead and do that. All right. So if two angles are adjacent, then they have a common side. And I kind of like saying if two angles are adjacent, not if angles are adjacent. You really can't have three adjacent angles. So if two angles are adjacent, then they have a common side. And this is a true conditional statement. Having a common side is part of the definition of adjacent. So if I call something adjacent, it has to have a common side. All right, write the converse by switching the hypothesis and conclusion. If two angles have a common side, then they are adjacent. This is the converse. Two angles are adjacent was the hypothesis, and now it's over here at the conclusion. And here they had a common side was the conclusion, and here it is as the hypothesis. This statement is false. Having a common side is only one of the 4 criteria that angles must meet in order to be called adjacent. So let's look at a counterexample. This angle here and this angle here. They share this side. They have a common side. They actually have a common vertex, and they're in the same plane. However, these are not adjacent. This is my counterexample. These overlap. These are not adjacent. Another counterexample would be the following. This angle here and this angle here have a common side right there. However, they're not in the same plane, so these are not coplanar. Therefore, these are not adjacent. And these are 2 counterexamples. Okay. So far we have our statements. If P, then Q. It's called the conditional. If Q, then P is called the converse. Okay. Now we have to do a little definition first, and then we'll do our next statement. The denial of a statement is called a negation. The negation of an angle is obtuse is an angle is not obtuse. If a statement is true, then the negation is false. So for example, if an angle is obtuse and that's true, then the angle is not obtuse must be false. If the statement is false, then the negation is true. All right. Just a little point here. An angle is obtuse. The negation is not an angle is acute. That would leave out the idea of an angle being a right angle. So an angle is obtuse. The denial of that statement is an angle is not obtuse. Okay, this is the notation we use, and that is read not P. So it's a little squiggly like this, like that. Not P. And that's how we use notation to indicate the negation. All right, so our third type of statement, so far we have the conditional, the converse. Our third type is called the inverse. Given a conditional statement, its inverse can be formed by negating both the hypothesis and the conclusion. The inverse of a true statement is not necessarily true. The inverse of if P then Q is if not P then not Q. And that's the inverse. Okay. So let's give it a try. Write the conditional in if-then form. Vertical angles are congruent if two angles are vertical, then they are congruent. Okay, now negate the hypothesis and the conclusion to form the inverse. If two angles are not vertical, then they are not congruent. There we go. And that's the inverse. Go ahead and pause the video, determine whether or not that inverse is true or false, and if false, give a counterexample. Okay. This is in fact a false statement. I can show you two angles that are not vertical. These are not vertical angles, but yet they're both 30 degrees. That's an angle bisector. So there's a counterexample. If two angles are not vertical, then they are not congruent. This is a counterexample to that statement. Okay.